For our fourth example of the quotient rule, we get to look at not only the quotient rule but also the product rule thrown in here. And so obviously from the first part you can see that we have a quotient of 3h minus 2 over 2h plus 5, but then we also have the product of 5h plus 1. And so our first step is actually to work the product rule, and you'll see as we're working the product rule where the quotient rule works itself in there. As I do the product rule, I'm going to think of this as u and this as v. And so my notation, I want to take the derivative of y with respect to h. So I have my u, I just rewrite it, dv, the derivative of 5h plus 1 is 5, plus v du. Now the v came straight down, but the du is where we're going to see that quotient rule. So in and of itself, we're going to do our low d high, the derivative of the top is 3, minus high d low, the derivative of the bottom is 2, over the denominator squared. At this point, we have a lot of algebra to work with, and so the first part I left alone. The second part I decided to go ahead and distribute here. So the second set of terms, I'm going to have 3 times 2h, which is 6h, 3 times 3 is 9. And then for the second part of my numerator up here, I'm going to distribute the negative and the 2 simultaneously. So negative 2 times 3h is negative 6h. Negative 2 times negative 2 is plus 4. On the next line, what I did was I took this 5 and I distributed it across that numerator to create the 15h minus 10. And then it seems like the second term just fell apart, and what happened there was 6h take away 6h drops out, 9 plus 4 gives me my 13. And then I took this multiplier and I decided just to bring it up as part of the numerator. So I had my 13 from the bracket, and then I said times 5h plus 1. I just brought that up as a multiplier there. And then as I'm looking at these two fractions, I see that they're very close in terms of their denominator. I'm just missing a factor of 2h plus 3 before I would have common denominators. And so in my next step, that's what I decided to do. I went for the common denominator. I decided to multiply this first fraction on the top and the bottom by 2h plus 3. As I multiply the first fraction by 2h plus 3, I'm really just going to FOIL this here. So 2h times 15h is 30h squared. Outer outer is 45h. Inner inner would be minus 20h. So 45 minus 25, or 20, would be 25h. And last with last was my negative 30. For the second fraction, I decided to go ahead and distribute the 13. So 13 times 5 would be 65h. 13 times 1 is 13. Over that common denominator. And then as a last step, I'd be able to combine like terms. And so I have my 30h squared, 25h plus 65 is 90h, and then the negative 30 plus 13 is minus 17 over the common denominator of 2h plus 3 quantity squared. That was our fourth example. Again, I like the example because we were able to see a couple of the rules in action at once, and in all honesty, that you're going to see that very often, where you have to do multiple things. In fact, in our next section, we're going to have something called a chain rule, where you're going to have multiple ideas running at once, and so it's something you need to get used to. For this one, again, it was the product rule, and then we had the chain rule, or not the chain rule, the quotient rule within that, and so this became a very nice problem to look at. Example 4.